Section 7.5, Systems of Linear Inequalities. When you solve a system of linear inequalities, the first thing you want to do is you want to select one of the inequalities. In general, you want to replace the inequality symbol with an equal sign to draw the graph of the equation. Once you draw the graph of the equation, you have to decide if you use a dashed line or a solid line. If your inequality symbol does not have a line underneath it, so it's either less than or greater than symbol, you are going to use a dashed line. If your inequality sign does have a line underneath it, less than or equal to or greater than or equal to, you will use a solid line. Once you have the line graphed, then you'll use a test point to decide which side of the line that you should shade. You'll repeat that step with the other inequality, and where the two shaded regions overlap is going to represent your solution set. So for example, if I gave you the system x plus y is less than 1 and x minus y is less than 5, and I asked you to graph those. So let's say we were going to graph x plus y is less than 1. You could pretend it says x plus y equals 1, and if you wanted, you could get your y isolated by subtracting x to both sides. So y would equal negative x plus 1. So that means you would start by graphing on the y-axis located at 1, and you would use your slope of negative 1. So you would go down 1, right 1, down 1, right 1, and I would fill in your grid like that. I would graph the whole equation. Now you have to decide which type of line type to use. Since we have just a less than symbol, we are going to use a dashed line. And you have to decide which side of the line to shade, because what we could do is we could do our test point of 0, 0. So if I tested 0, 0 and substituted it into the equation, 0 for x and 0 for y, let's see if it makes a true statement. Is 0 plus 0 less than 1? It is, so I would shade the side of the graph that had the test point on it. If the test point was false when I substituted it in, then I would shade the other side of the graph. Okay, now I need to repeat this procedure with the other inequality. My other inequality is x minus y less than 5. So again, I would just pretend that it says x minus y equals 5. You can solve for y. You could also just find your x-intercept. If you want to find your x-intercept, just zero out the y. Your x-intercept in this problem is going to be 5. So on the x-axis, you would plot a dot at 5. And if you want to find your y-intercept, just zero out your x. Your y-intercept is negative 5. So we come down here to negative 5 on the y-axis. Again, you have to decide what type of line you're going to use. Because there's no line underneath the inequality, we again need to use a dashed line. You'll need to make sure to select the right line type in my math lab or you're going to get it wrong. And then we also need to try a test point. So I'm not very unique, so I typically test 0, 0 unless I'm going through that point. Is 0 minus 0 smaller than 5? It is. That is a true statement. So I will end up shading where the test point was located. Now, your solution set is where the double shaded region occurs. Okay, so in this problem, our solution set is going to be this area where the blue and the red overlapped each other. That's your solution set right there. The lines themselves are not part of the solution because they are dashed, so they're not included in the solution set. Let's look at another one. Let's say I gave you the inequality 4x minus 2y is greater than or equal to 8. So the easiest way to graph that is to find your x and y intercepts. So if you want your x-intercept, you need to zero out the y. So you'd have the equation 4x equals 8. So x would be 2. You'd plot that point on your x-axis. If you want your y-intercept, you would need to zero out your x. So you'd have negative 2y equals 8. So you'd have to divide each side by negative 2. So your y-intercept would be -4. So you'd plot that on your y-axis. Because the inequality symbol has an equal to, you are going to use a solid line. And then you'll have to test a point. So let's test the point 0, 0. Is 4 times 0 minus 2 times 0 bigger than or equal to 8? Well, 4 times 0 is 0, and 2 times 0 is 0, so it's saying that 0 is bigger than 8. That's false, so you should shade the side of the line that the test point is not on. So in this case, it's going to look like you're going to the underside of the line. Okay, now you need to graph your other inequality. Our other inequality is 2x plus 3y less than 6. Again, I'm going to use the intercept method. 2x plus 3y equals 6. To get my x-intercept, I'm going to zero out my y. And my x-intercept is 3. To get my y-intercept, I'm going to zero out my x. And my y-intercept is 2. Since the inequality does not have a line underneath, I will have to connect the dots with a dashed line. And then I'm going to try my test point method. Again, I'm going to test the point 0, 0. So if I substituted that in, 2 times 0 plus 3 times 0, is that smaller than 6? Well, 2 times 0 is 0, and 3 times 0 is 0, and 0 is smaller than 6. So I would shade to the side that the test point is on. Now notice where the blue and the red are overlapping. This little wedge would represent your solution right there. Also, the red line would be part of the solution because it's solid, but the blue line, dashed line, would not. One last example. Graph the following system of inequalities and indicate the solution set. The first is the inequality y is greater than or equal to -2. X is greater than or equal to -2. X equals a number is going to be a vertical line. So keep in mind that x equals -2 on all the points that run vertically with -2. So because there's a line underneath my inequality symbol, I am going to use a solid line. And then I have to decide which side of the line to shade. Am I shading to the right or to the left? So I'm going to test 0, 0. Is 0 bigger than or equal to -2? That is a true statement. So I'm going to shade the right side of the line. And on the computer, when you shade, you'll have to use the little paint can feature. Now I need to graph y is less than 3. Y equals 3 is a horizontal line. It is going to be a dashed line because there is no inequality, an equal to sign with that inequality symbol. And again, I'm going to test 0, 0. Is 0 smaller than 3? It is, so I'm going to shade towards the test point again. And my solution would be in this bottom rectangular area right here where the double region occurs. Okay? All right, give your homework a try. Let me know if you have questions.